So, our lesson for the week, we are going to start right here. Atomic number, talk lots about it. So, it is the number of protons in the nucleus. All the elements on the periodic table are arranged, organized based on atomic number. Hydrogen has 1 proton, its atomic number is 1. Helium has 2 protons, its atomic number is 2, and that continues in order. You would read the periodic table like you would a book, from left to right and down. This week, we're going to talk a little bit more about atomic mass. So I want you to think of mass as weight, how much something weighs. So you could be like, whoa, that thing is massive. So you're suggesting that it weighs a lot, also that it's big. And so as we look through the periodic table, as you were to read it, you would notice that because each element starts to have more protons in the nucleus, it'll actually weigh more. Okay, so hydrogen is the lightest element, and so it only weighs arguably 1 gram. And if we continue, helium will weigh a little bit more than boron, and so on and so on. And so atomic mass is the weight of the element. Okay. In grade 10, you're going to talk about what is molar mass. And so you're going to get a little bit more specific as to how much it actually weighs. And so you'll be able to do those calculations. We're not going to do that in grade 9. I just want you to think of it as the weight of it. Okay. And so as you go through the periodic table, something like uranium that has 92 protons in the nucleus weighs significantly more than something like hydrogen. We talked about the element symbol. So the symbol is rooted in Latin, so it's not always going to correlate with the name. So something like gold, for example, in Latin, it's aurum. So its symbol is actually Au, okay, not G. Ion charge we'll talk about a little later. But so an ion charge is actually looking at the number of electrons an atom has and whether or not it likes to lose an electron or gain an electron, which we'll talk about later. So ion charge is the element's charge. Okay. So I want to do a little practice here. I want to look at, and usually in class, I get you guys to come up to the smartboard and do this with me. But we're going to do it like this. So hydrogen, I would want you to tell me what the atomic number is. So here, if you look at the tile of hydrogen, you'll see at the top left-hand corner 1. So that's how many protons it has. And so hydrogen has 1 as its atomic number. Then the symbol for hydrogen, this is asking for the name. So the name would be hydrogen. If I asked you for the symbol, it would be H, okay? And then the atomic mass. So the atomic mass is actually found below the symbol and below the name. And typically it's a decimal. So it's going to not be a whole number like the atomic number, but it's typically a decimal. Some periodic tables will give you a decimal to 2 places or 3 places. So just go off of what periodic table I give you and write out the whole number as the decimal. So the atomic mass, the weight of hydrogen, is 1.008 here. Okay. If we look at something like lithium, I can erase on here. Brings you back to our smartboard days. If you look at lithium, okay, its atomic number is 3, so up in the left-hand corner. Okay, its name is lithium. The symbol would be Li. Always make sure that this first letter is uppercase, it's a capital, and that the second letter is always lowercase if there is a second letter. The atomic mass here is going to be 6.95 this is hard on my laptop. Just using a little trackpad, okay? 6.941. That is the atomic mass. That's how much it weighs, okay? Then if we look at beryllium, okay? Beryllium, the atomic number up in the left-hand corner, how many protons it has, is going to be 4. The name is beryllium. Its symbol would be Be. Again, capital and then lowercase, okay? And then the mass, how much it weighs, is going to be 9.012, okay? We'll continue. And we will look at sodium. So sodium's atomic number there is 11. So it has 11 protons in the nucleus. Its name is sodium. Let me try and write this. So, whoa, it's not cooperating with me anymore. Sodium, if you can read that. But then its symbol is actually Na, capital, lowercase, okay? Sodium is rooted in Latin. The symbol is rooted in Latin, so it's not going to be SO, okay? Then its mass is going to be 22.990, okay? Then the last one, magnesium. And we could do this for the whole entire periodic table. These are just some examples that I want to go through. If I look at magnesium, I don't know if you can see it there, its atomic number is 12. Whoops, 12. The name is magnesium. Symbol would be getting really slow, G. And the mass, how much it weighs, is going to be 24.305. Okay. So that's looking at atomic number, element name and symbol, and then atomic mass. I want to make note that the atomic mass, how much an element weighs, we gather that information by looking at the number of protons and neutrons inside the nucleus. So if we look at lithium here, Li, its atomic number is 3. So in the top left-hand corner, we have 3. So if you were to draw lithium using the Bohr model, you would see that it has 3 protons in the nucleus, okay? It would also most often have 3 neutrons in the nucleus, okay? And then it will also have 3 electrons orbiting the nucleus. Okay, and you'll see here that in the first ring, the most inner ring, there are only 2 electrons. It caps at 2 electrons. Then in the second ring, for that third electron over here, I have it floating in a separate ring. Okay, that's the Bohr model. Okay, Bohr, Niels Bohr. And so the weight of it, okay, think of each subatomic particle in the nucleus as weighing 1, okay, 1 gram. So I have 1 proton, 2, and then 3. So that weighs 3. But then I also have neutrons in there. 1, 2, 3. okay? So arguably, lithium should weigh 6 grams, right? It has 3 protons and 3 neutrons, so it weighs 6. But you have a decimal for the mass, the weight of what this element weighs. And the reason it's a decimal is because it's an average, okay? So lithium actually, sometimes it will have 3 protons and 3 neutrons. But depending on where I find this element in the world, okay, what it's doing, again, where I found it, some of them might actually have 4 neutrons in the nucleus. And it's still lithium, okay? It's still lithium because it has 3 protons. Those protons, those positively charged particles, these red ones that I'm drawing, the ones that are all about the atomic number, they are what characterize an element. So if I tell you something has 3 protons, you always know it's lithium. It'll never be anything different. But if I find lithium with 3 protons and 4 neutrons, it's still lithium. Okay? It's what we call an isotope, which we'll get into later. And so isotopes have a different number of neutrons than protons. Okay? And so when we look at the periodic table, the weight of lithium, sometimes it'll weigh exactly 6 grams. Sometimes it will weigh closer to 7. And so chemists have come up with an average. So what do we most often see? Okay, so we most often see actually lithium that has 3 protons and something closer to 4 neutrons because it weighs 6.941. That's the mass. Okay, so that's an average. So that's why atomic mass, the weight of an element or an atom, will be a decimal because it's an average. Okay, there's going to be another screencast video after this that I'm going to get you to watch, where we look at kind of the organization a little bit more of the periodic table. Okay, see you guys later. Bye.